Hello IE48A folks, today I will introduce you Purr package of R in the name of our group R slash. It is a package that fills the missing parts in R's functional programming tools. If you have never heard of FP, functional programming tools before, the best place is to start is the family of map functions, which allow you to replace many for loops with code that's both more concise and easier to read. I can give you some example about map functions family. For instance, map character, which gives you a vector of characters in the end of process applying iteration on your subjects easily. Another example of mine is map underscore dbl function, which gives you a vector of numbers in the end of the same process with map underscore character function. This Purr package is the response of Tidyverse. Tidyverse is also a very good package, as you know, in the name of enhancing R's functional programming, but it lacks on iteration subjects. It doesn't help you much when you're determined to use many loops on your work. Purr package responds beautifully exactly on this point. Now, my group friends will explain how it works and give you examples from where it makes things easier.
Imagine reading in hundreds of files with a similar structure and performing an action on them. We don't want to write hundreds of repeated lines of code to read or execute the operation in all of scripts. We want to iterate about them. Iteration is the mechanism by which many inputs do the same thing. Iterating is essential to make our code efficient and is powerful when working with lists. The names of 16 CSV files for this exercise have been loaded into a list called data. We may use list.files function to build the list in our own work. Even the reader library is loaded already. We have been we have made a nice loop, but it needs a lot of code to do same thing as basic as adding in a list a set of files. This is where Purr joins. In one line of code, we can do the same thing as a for loop with pure map. The map function iterates over assets and uses a different function that can be defined with the .f argument. Map takes the two arguments. The first is the list over that will be iterated over. The second is a function that will act on each element of the list. The reader library is already loaded.
We can do reading with iteration, but not only that. We can also perform other behavior. First, we try to iterate with a loop. We turn each element in a list into a form of numeric data and then place it back in the same element in the same list. We will iterate using a for loop which takes list of df. List of df is a list of vector characters, but the characters are actually numbers. We convert the character vectors to numeric to allow us to perform mathematical operations on them. We can use the base R function as numeric to do that. Now, you will change each element of a list into a numeric data type and after that put all of them in the same list. But we can use map function to solve problems easily instead of using a for loop. We can use map function in Purr to create a loop on the list easily, and characters will be turned to numbers. We will use just one line instead of writing a whole for loop.
We have to refresh our memory to understand how pipes can be used between functions. We can also use pipes inside of map function to help you iterate a pipeline of tasks over a list of inputs. We will work with list of numbers instead of recursive datasets so that we can do mathematical operations. When many of us trying to solve a problem with data, we first need to build some simulated data to see if our idea is even possible. In this exercise, we will do how this works in Purr by simulating data for two populations, A and B, from sites north, east, and west. Two populations will be randomly drawn from a normal distribution with different means and standard deviations.
With map, you can do not only calculating the square root of a number of simulating data, but also iterating over different inputs to run several models, each of them using the unique values of a specified list element. You can also repeat for the models you have run to produce the model summarize and examine the outcomes. The map function is very effective if you need to loop over one list. However, you will often need to loop over two lists simultaneously. This is where map2 function gets in. While map function takes the list as x parameter, map2 function takes two lists as two parameters x and y. To test out map2 function, you are going to produce a basic data set with one list of numbers and one list of strings. You will put these two lists unitedly and produce some simulated data.
What if you need to loop over three lists? Is there a map3 function? To loop over more than two lists, whether it's 3, 4, or even 20, you need pmap function. However, pmap function requires our list arguments a bit differently. To use pmap function, you first need to produce a master list of all the lists we want to loop over. The master list is the input for pmap function. Don't use the .x or .y. Use the list names as argument names. You are going to simulate data for the last time, using 5 lists as inputs instead of 2. Using pmap function gives you complete control over our simulated dataset and will let you use 2 unique means and 2 unique standard deviations along with the unique sites. Thank you for your attention.